Welcome to our video on machine learning fundamentals. We're excited to take you through the fascinating world of machine learning. Today, we'll explore supervised learning, unsupervised learning, and reinforcement learning. In this introduction, we'll give you a brief overview of what's to come. You'll learn how each paradigm tackles different problems, their strengths, and where they are most effective. Whether you're a student, professional, or enthusiast, this video aims to build a solid foundation in machine learning. Let's begin by exploring the capabilities and applications of these paradigms. Stay tuned as we unravel the mysteries and practical uses of machine learning from the ground up. Machine learning, a branch of artificial intelligence, focuses on building systems that learn from and make decisions based on data. Essentially, machine learning models analyze vast amounts of data, identifying patterns and making informed decisions without human intervention. This is crucial in today's data-driven world, enhancing applications across various fields from healthcare to finance. Understanding the basics of machine learning is vital, setting a solid foundation for exploring its diverse paradigms. Stay tuned as we embark on this educational journey together. Imagine you have a large data set and need to make sense of it. How do you classify, cluster, or make decisions based on this data? With ever-growing information, traditional methods fall short. This is where machine learning paradigms come in. By leveraging their power, we can transform raw data into meaningful insights, decisions, and predictions. Whether it's labeling data in supervised learning, discovering hidden patterns in unsupervised learning, or optimizing decisions in reinforcement learning, machine learning techniques provide robust solutions. Let's explore how each paradigm tackles specific aspects, equipping us to navigate complex data with greater accuracy. Supervised learning is a foundational paradigm in machine learning, where the model is trained using labeled data. Each training example has an output label. For example, imagine a dataset with images of animals and their respective species. The model learns to predict species by finding patterns between images and labels. Through continuous improvement, supervised learning algorithms can accurately classify new unseen examples. We'll delve deeper into these algorithms, showing how they solve real-world problems and demonstrate the effectiveness and versatility of supervised learning. Imagine this scenario: your email inbox flooded with countless messages, some crucial, others clear spam. How does your email provider decide which is which? Enter supervised learning. Supervised learning is a vital tool in machine learning, and email spam detection is one of its most practical applications. The process begins with a training dataset, which contains thousands of emails meticulously labeled spam or not spam. This labeled data equips the model with the necessary context to learn from. As the model processes this data, it starts identifying patterns, words, phrases, and structures that are common in spam emails. For example, phrases like winning cash prize or urgent action required often indicate spam. Initially, a human annotates a sizable collection of emails, assigning either the spam or not spam label to each one. This dataset is then fed into the supervised learning model. The model uses these annotations to learn and create classification rules. As training progresses, the model becomes adept at distinguishing spam from legitimate emails. When a new email arrives, it scrutinizes the content using learned patterns. If the new email's features match known spam patterns, it gets flagged as spam. Otherwise, it goes to your main inbox. This automated classification happens almost instantaneously, ensuring a seamless user experience. The model continuously improves with new data, adapting to changing spam tactics over time. Supervised learning's strength lies in leveraging labeled data to make accurate predictions. It's not just about blocking spam. Similar principles apply to detecting fraudulent transactions, diagnosing diseases, and more. Next, we'll explore unsupervised learning and how it uncovers hidden patterns in data. Unsupervised learning is a type of machine learning where the model is trained on unlabeled data. Unlike supervised learning, there are no predefined labels to guide learning. Instead, the system identifies patterns and structures within the data by itself. This approach is useful for tasks such as clustering, where the goal is to group data points based on similarities. By finding these hidden structures, Unsupervised learning helps make sense of complex datasets without prior knowledge of their classifications. Now that we've understood the basics of unsupervised learning, let's explore a real-world example that demonstrates its potential. Let's explore a practical example to see how unsupervised learning works. Imagine you are a retail business owner with thousands of customers, each having unique purchasing behaviors, but no predefined categories. This is where unsupervised learning comes into play. You can use unsupervised learning algorithms to analyze this vast dataset and uncover hidden patterns. For instance, in customer segmentation, unsupervised learning can group customers into different segments based on buying habits. The algorithm identifies natural clusters without needing prior labels. By segmenting customers this way, you can tailor marketing strategies to different groups. For example, if the algorithm discovers a segment of customers who frequently buy high-end electronics, you can create targeted promotions for this group, significantly increasing marketing effectiveness. This approach helps refine marketing efforts and enhance customer satisfaction. By understanding the unique needs and preferences of each segment, you can personalize your services and products, leading to stronger customer loyalty and higher retention rates. Unsupervised learning transforms a chaotic dataset into meaningful insights, empowering businesses to make data-driven decisions. It uncovers underlying data structures, revealing patterns that would otherwise remain hidden. Next, we'll see how another paradigm, reinforcement learning, enables an agent to learn and make decisions by interacting with its environment, receiving rewards and penalties. Welcome to reinforcement learning, a fascinating type of machine learning. Unlike supervised and unsupervised learning, reinforcement learning involves an agent learning to make decisions by performing actions and receiving feedback in the form of rewards or penalties. This feedback guides the agent to optimize its behavior over time. Imagine training a dog with treats for good behavior and corrections for mistakes. Reinforcement learning works similarly. The agent seeks to maximize cumulative rewards through trial and error, discovering the most effective strategies to achieve its goals. Let's explore how this paradigm is applied in real-world scenarios. In our journey through machine learning, we've arrived at reinforcement learning. Let's explore an example to see how it works. Imagine a robot navigating a complex maze. Our challenge is to teach the robot to find its way to the exit efficiently. This is where reinforcement learning shines. Each step the robot takes is an action, and the maze is its environment. As the robot moves, it receives feedback in the form of rewards and penalties. If the robot moves towards the exit, it earns a reward. If it hits a wall, it encounters a penalty. Over time, the robot learns to associate certain actions with positive outcomes, optimizing its path to minimize penalties and maximize rewards. This learning process is not instant. Initially, the robot makes mistakes, hits walls, and takes wrong turns. But with each attempt, it gains experience, learning the maze's layout through trial and error. Reinforcement learning's beauty lies in its adaptability. It's not rigidly programmed with rules. Instead, it figures out the best strategy through continual interaction with its environment, much like how humans learn from experiences. In our maze example, the robot eventually develops an optimal strategy to navigate efficiently, applying what it has learned from trials. This method can be applied to various problems, from game playing to robotic control and financial trading. Reinforcement learning offers powerful tools for decision-making and strategy in dynamic environments. Next, we'll compare the paradigms we've discussed: supervised, unsupervised, and reinforcement learning, highlighting their unique strengths and applications. In our journey through machine learning, we've explored supervised, unsupervised, and reinforcement learning. Now, let's compare these paradigms to understand their unique strengths and weaknesses. Supervised learning is powerful for classification tasks, relying on labeled data to guide the model's training. This method excels when you have a well-defined output, such as identifying spam emails or diagnosing diseases from medical images. However, its dependence on labeled data can be a limitation when labels are scarce. In contrast, unsupervised learning uncovers hidden data patterns without labels. This approach is superb for tasks like customer segmentation, where groups are not predefined. The model identifies inherent structures based purely on data characteristics. This can lead to insightful discoveries, though results can be less predictable and harder to evaluate. Reinforcement learning is tailored for dynamic decision-making in complex environments. Using rewards and penalties, the model learns optimal behaviors over time. Think of a robot navigating a maze, learning the best path through trial and error. This paradigm is adaptive but can be computationally intensive, requiring extensive interactions to reach proficiency. Each paradigm has its niche: supervised learning for clear-cut classification, unsupervised learning for pattern recognition, and reinforcement learning for agile decision-making. Understanding these strengths and weaknesses helps you choose the appropriate paradigm for your machine learning challenge. Next, let's explore how to select the right paradigm tailored to your needs. Choosing the right machine learning paradigm is crucial to your project's success. Consider the nature of your data, the specific problem you're solving, and available resources. Supervised learning is ideal when pre-labeled data is available and the goal is accurate predictions. Unsupervised learning shines in uncovering hidden patterns in unannotated data. Reinforcement learning suits scenarios requiring interdependent decisions with actions rewarded or penalized over time. Evaluating these factors helps you select the paradigm that best fits your needs. Next, we'll explore real-world applications to see these paradigms in action. In the real world, machine learning paradigms play pivotal roles across diverse industries. Supervised learning revolutionizes healthcare by analyzing patient data to predict illnesses early and suggest treatment plans. In finance, unsupervised learning profiles customer behavior without predefined labels, unveiling patterns and trends for investment strategies. Reinforcement learning drives advances in robotics, especially in autonomous driving, where agents learn optimal driving policies through rewards for safe maneuvers and penalties for errors. These applications show machine learning paradigms' transformative power. In healthcare, supervised learning models predict medical conditions and personalized treatments, improving patient outcomes. Unsupervised learning in finance helps companies understand consumer segments, enabling precise marketing and product recommendations. In autonomous vehicles, reinforcement learning equips robots to navigate complex environments, ensuring safety and efficiency. These paradigms are more than theoretical concepts. They solve real-world problems, improve lives, and drive business success. Moving forward, you'll see how these paradigms continue evolving and reshaping industries in unexpected ways. The future of machine learning is incredibly promising. We're poised for groundbreaking advancements in deep learning, with algorithms reaching unprecedented sophistication. Quantum computing is set to revolutionize data processing speeds, making machine learning models more powerful and efficient. AI ethics will ensure responsible technology evolution, balancing innovation with crucial ethical considerations. Imagine intelligent systems performing complex tasks and making ethical decisions. Embracing these advancements is essential to shape the intelligent systems of tomorrow. Stay tuned as we summarize key points from this video, recapping machine learning's foundational paradigms and their impactful applications. To summarize, we've explored the primary machine learning paradigms: supervised, unsupervised, and reinforcement learning, along with their applications. Supervised learning uses labeled data to classify or predict outcomes. Unsupervised learning finds hidden patterns in unlabeled data, aiding tasks like customer segmentation. Reinforcement learning allows agents to learn through rewards and penalties, crucial for decision-making in dynamic environments. Understanding these paradigms gives you a fundamental grasp of machine learning's potential in solving various problems. As we move forward, you'll see how these concepts transform industries and shape the future. Next, we provide additional resources for further learning. For those eager to dive deeper into machine learning, we've got you covered. Explore the description links for additional resources and courses. These materials help expand the concepts we've discussed and delve further into supervised, unsupervised, and reinforcement learning. Whether you're a student, professional, or enthusiast wanting to refine your understanding, these resources support your journey. Happy learning! If you found this video helpful, please like, subscribe, and share it. Your support helps us create more content like this. Leave your comments and questions below. We love hearing from our audience and we'll do our best to respond. Your feedback and engagement are vital for us to keep improving and providing valuable content. Thank you for being part of our learning community. Up next, enjoy our thank you message. Thank you for watching. We hope you enjoyed learning about machine learning paradigms, supervised, unsupervised, and reinforcement learning. Your time and interest are truly appreciated. Machine learning is a fascinating and rapidly evolving field, and we're grateful you joined us on this educational journey. Don't forget to explore the additional resources and apply what you've learned to your projects. Stay curious and keep learning. Until next time, thank you and take care. We hope you've gained valuable insights into the fundamentals of machine learning. Now equipped with this knowledge, dive deeper. Check out these other videos to expand your understanding. If you haven't already, hit the subscribe button to stay updated on our latest educational content. Your journey in machine learning has just begun, and there's so much more to explore. Stay curious and keep learning.